Well, hopefully you're really good at solving those one-step equations, because the I can statement for section 3.3 is I can solve two-step equations. So as the warm-up, let's just review these ideas, because these ideas are really important. The goal of solving an equation is to get the variable on one side all by itself, so we can read the answer off on the other side. And the answer, aka also known as the solution, we kind of use those words interchangeably, is the number that makes the equation true. So if we plug it back in, it makes the equation true. And I've got a couple problems here just to kind of practice on, make sure we're good at solving those. So solve each one of the equations on your own, show your thinking, in other words, show your work, and then circle your answer. So normal work process on each one of these. And again, if you want to pause the video and then check your answers after, that would be great. But I'll go ahead and solve. So on this first one, we want to undo subtracting 16s, or sorry, adding 16. So I'm going to subtract 16 from both sides. These cancel to be 0. Important to think about it that way. So I get a y on this side, and on this side I get negative 26 once I combine those integers. So I'll circle my answer. There's my work. There's my answer. On this problem right here, I need to get rid of that 4. Now that's understood to be a positive 4. There's no sign in front of the 4, so that's going to be a positive. So I'm going to subtract 4 from both sides. That's going to give me a 3 on this side. Remember, those cancel to be a 0. And I get negative a. And then we can't stop right there, because this is not the answer. The variable's not by itself. We don't want negative a. We want its opposite. We want positive a. So we don't want positive 3. We want negative 3. There's the answer there. And if you wanted to do that by dividing both sides by a negative 1, that would be totally okay. Let's take a look at this one here. 13 times b equals 52. We're going to divide both sides by 13 to undo that timesing by 13. Those cancel, but remember, they cancel to be a 1. So we've got our 1b over here, and then 52 divided by 13. Might need to think about that. If there's no problem, if you have to do long division or something, let's always a good idea to review those occasionally, but the answer on that one would be positive 4. And again, you could plug that in and make sure that it makes the equation true if you wanted to. We're going to undo dividing by negative 4. We're going to multiply both sides by negative 4. So again, I'm going to put that second factor in parentheses. Negative divided by a negative, that's going to cancel to be a positive 1, just like we want over here. And then this is going to be a 40, so the answer there is 40. So hopefully you got all those right. If you did, then you're in really good shape and ready to go on this next section and next idea, because this is a little bit more complicated, but really, really important. So in the last section, we solved one-step equations, which required, of course, just one step. In this one, we're going to take a look at equations that require more than one step. Now, if you learn the concepts we're going to talk about today, you're going to be better able to solve any equation that you come across in the future. So here are the fundamental ideas involved in solving almost any equation. So here are the ideas. So let's fill these in and let's talk about what they mean. So step number 1, isolate the variable term. Isolate the variable term. And the second step is, then we're going to isolate the variable. So isolate the variable term and then isolate the variable. Now the word isolate means get by itself, and we've actually talked about that before. So up here we were saying the goal is to get the variable on one side all by itself, or in other words, the goal is to isolate the variable, and we're going to do that a step at a time as we solve these. So it says solve each equation using inverse operations, and it's important to undo the operations in the correct order. So what I want you to stop and think about is x divided by 9 plus 2 equals negative 7. So we want to isolate the variable term first. This is the variable term. So sometimes what I'll do is I'll actually kind of cover that up, and I realize you can still see that. But this is the variable term. That's what we want to get by itself. So we want to undo the adding 2. So we are going to subtract 2 from both sides. So if I do that, these are going to cancel each other out. They're going to cancel to be a 0. On this side I end up with a negative 9, and remember over here we didn't touch that at all. We were isolating the variable term. So here's that variable term that we got by itself. So you'll notice that we took one step and we're not quite done yet. We now have one more step to do. We need to undo dividing by 9. So I'm going to multiply both sides by 9, put that second factor in parentheses. 9 divided by 9, those cancel each other to be a 1, and then over on this side I get negative 81. Negative 9 times positive 9 would be negative 81. This right here is the answer. So you'll notice that it took 2 steps in order to solve that. When we were isolating this variable term, we got rid of adding 2 first by subtracting 2 from both sides, and then we undid the dividing by 9 by multiplying both sides by 9, and we just showed our work for each one of those. Now I'm not going to check every one of these, but I am going to check this particular one, so I'm going to plug in a negative 81 right there. So negative 81 divided by 9 plus 2, that better equal negative 7. If not, we've done something wrong, so I'm going to put a question mark there. Negative divided by a positive, we're going to do the order of operations, do division before we do addition. So this is going to be negative 9 plus 2 equals negative 7. Does negative 9 plus 2 equal negative 7? It does. So this checks out. That's the right answer. So it's really important that we do things in the correct order, and we're basically undoing the order of operations, and we'll take a look at that a little bit more later on. But let's take a look at this right here. So we're going to isolate the variable term, then isolate the variable. So this is the variable term. The negative 5x is the variable term. So again, if you need to cover that up, circle it or something like that. Sometimes I'll put my thumb over the top of it to cover that up. And then I'll figure out, okay, I need to undo this right here. I need to undo adding 7. So I'm going to subtract 7 from both sides. This gives me a negative 10 over here. I've still got that variable term right here. So I've got negative 5x on this side and negative 10 there. I'm going to undo that implied multiplication by 5 by dividing by negative 5. So over on this side, those cancel to be a 1, which is what I want. And let's see, negative divided by negative is positive. 10 divided by 5 is 2, so the answer on this one is 2. And again, you could check that if you wanted. So let's take a look at this one right here, the next one. Here's the variable term. So what we need to get rid of is we need to get rid of this subtracting 6. So we're going to add 6 to both sides. So if we add 6 to both sides, this is going to give us an 18 over here and an 8y over here. So we got the variable term by itself. Now we're going to get rid of that timesing by 8. So we're going to divide by 8. Now those cancel to be, let's see, 8 divided by 8, yep, that cancels to be a 1y. Now over here, some people look at this and they freak out and they go, oh my gosh, we must have done something wrong. Now this is not going to happen very often on the assignments that we've had so far, but I do want to mention this at this point. So far we've always gotten integer answers, but if you did run across something like this, it is possible to look at this and say, okay, well, what do we do with this? You'll notice that 8 doesn't go into 18 evenly. So what I tell students to do is stop thinking of this as a division problem and think of it as a fraction. And what we'd want to do is we'd just want to reduce this fraction. So we think of what goes into both of those evenly so that I can reduce those. Well, they're both even, so 2 goes in here 9 times. Whoops. 2 goes in here 9 times. And 2 goes in here 4 times. So this would be just fine for an answer. Now again, you're not going to run into very many like that, but I do kind of want to run that past you, just kind of get you thinking in that direction, so that if you do see something like that in the future, that you know how to handle it. So keep that in mind. And we always write things as, almost always write things as improper fractions when we're dealing them once we get to 7th grade and algebra and that sort of thing. So let's take a look at this next one right here. Here is the variable term right here. That's the variable term. So we want to get that by itself. So what we want to do is we want to undo that 4 right there. And again, that's an understood positive 4. So we're going to subtract 4 from both sides. That's going to give us a negative 10 over here. We're left with that variable term because those cancel out to be 0. So that's x divided by negative 10. So I've got x over negative 10 equals negative 10 over here. I need to undo that dividing by negative 10. So I'm going to times both sides by negative 10. Negative 10 divided by negative 10 is positive 1. Those cancel to be 1. And I end up with a 100 over here. Now, on this problem, it's a little bit unusual to see so many of the same numbers crop up, but totally okay. If you were to plug this in, it would make the equation true, and that's the whole point. So don't get freaked out if, some numbers look the same or something like that. All right, let's take a look at this one right here. Here's the variable term right there. And we want to get that by itself, so we want to undo the subtracting 2. So we're going to add 2 to both sides. That's going to give us negative 13 here, and then I've got negative x over 5. Now, I want to point this one out for a reason. There are a couple things that we could do here. We could undo the dividing by 5 by multiplying both sides by 5. That would be totally okay. We'd get negative 65 on this side, and we'd get negative x over here. Now remember, we don't want negative x, we want its opposite, we want positive x. So we don't want negative 65, we want positive 65. And there's the answer to the equation. Yeah, we're done. Now, if you wanted to, we could do this at this stage right here. We could think of this as, well, I need to cancel out the dividing by 5, so I'm going to multiply by 5, but I also need to cancel out that. So I could multiply both sides by negative 5, and you'll notice what happens here. Negative times a negative is positive, the 5's cancel to be a 1, and negative times a negative is positive, so we end up with 65 there. So same answer either way, so you've got a couple different options. Kind of keep that in mind because that may be useful. All right, let's take a look at this one, and then we'll look at some interesting ones. So let's subtract 3 from both sides, isolate that variable term. Those cancel to be 0. Negative 9k equals negative 72. And then we're going to divide by negative 9 to cancel off that timesing by negative 9. Those cancel to be a 1, so we've got a 1k over here. And we've got, let's see, negative 72 divided by negative 9 is positive 8. So there's our answer on that one. Now, I do want you to understand why we isolate the variable term first, and the reason we do that is because of the order of operations. So we're going to solve each of these equations, and you might notice these. I think we did some of these before. They're right up there, so we already know what the answers are. I want you to think about the order that the operations were done. So we're going to list the operations that were done, and then we're going to undo them. So we took x, or they took x, they divided by 9 first, and then they added 2. So the first thing they did is they divided by 9. The second thing they did is they added 2. So it should make sense if they did this first and this second. If we're going to undo those things, we don't want to undo this one first and then undo that one. So if we were going to undo adding 2, we would subtract 2 from both sides. So we get x over 9 equals negative 9. And then we would undo dividing by 9 by multiplying both sides by 9. So we get x equals negative 81. Same answer as we got up above, and you can kind of check that. And then on this one right here, so if we start out with x, so kind of like that game that we played in that warm-up the other day, if we started with x, the first thing that they did was multiply by negative 5, and then they added 7. So first thing they did is they multiplied by negative 5, and then the second thing they did is they added 7. So if they did first thing, then second thing, we're going to undo the second thing, and then we're going to undo the first thing. So we're going to undo adding 7 by subtracting 7. So this is negative 10 over here. Those cancel each other out, so we get that negative 5x. And then we're going to divide both sides by negative 5, because that's going to undo timesing by negative 5. So we get x equals 2 here. Same answer as we got up above. We can kind of take a look at that and make sure, yep, got those right. But that's kind of why we isolate the variable term first. Now, you don't have to do it this way or think about it this way, but it can be very helpful sometimes. What I'm interested in is, can you do the work this way when you're solving two-step equations? So go ahead and get started on that assignment, and good luck.